Welcome everyone. We're going to talk about probabilities. This is the beginning of the end for you. Probabilities, first off we're going to talk about independent probabilities, which is sample with replacement. Imagine rolling a die. If you roll a 2, you don't mop the 2 off the die. Then there's dependent probabilities, which is sampling without replacement. Think about playing cards. Once a card is dealt out, it's not put back in, so it changes the probabilities. Next we have joint probabilities, where we use the word or, which stands for more, and which is less. And we talk about binomial distribution. So for instance, or, which means more, the probability of getting a 3 or a 2 is going to be 0.167, which is 1/6 over 1/6 again. We add those two together, becomes 0.33, which is 1 over 3. Now, if I toss a die, what is the probability I'll get a 3 or a number that starts with the letter T? So the previous question assumed that the events are mutually exclusive, meaning you can't have both. However, we can have numbers that start with T, such as 2 and 3. They both start with T on a die. So we're going to have 0.167 for number 3, and then T, we have 2 and 3, and then since they're joined, both of them, probability of A and B, we subtract it. So we have 0.33 because still we only have 2 numbers. If I toss a die twice, what is the probability of getting a 3 both times? So that's going to be a multiplication rule, because and is harder. Think about it. If you're looking to date somebody, and if you want them funny or handsome, then you have more options. But if you want somebody who's funny and handsome, you have less. So we would do 1/6 times 1/6, which is going to be 0.0279. So let's imagine I'm choosing a random name out of a hat twice. What is the probability of getting a male's name both times? This is going, we'd have to do it either with independent. So we'd multiply it. And then we'd go on to the next example, which is if I toss a coin twice, what is the probability of getting that tails both times? And so that's going to be 1 over 2, which is going to be 0.5 times 0.5, and we have a sampling distribution that looks like this. What if I did it 3 times? It's going to be 0.5 times 0.5 times 0.5, which will give us essentially 1 out of 8, and a sampling distribution that looks like this. Now notice it's becoming to look more and more normally distributed. 10 times 0.5 to the 10th power, which is really just 0.5 times 0.5 times 0.5, so on until we have 10 times, which gives us 0.098. And then look at that. Looks really well like a normal distribution. Now we're going to start talking about hypothesis testing. So at the beginning we're going to talk about if we're playing with cards. What's the probability of getting red? What's the probability of getting black? So if the deck is normal, we'd assume it's a 50-50 shot, which is why it becomes probability of red equals the probability of black, 50-50, 0.5, 0.5. The alternative hypothesis would be that the deck is not a good deck, that we are missing cards, but we don't know which, so therefore we would say not black. Now, when we test hypotheses, we have correct ones where we decide to reject the null when it is indeed false, and when we decide not to reject the null when indeed it is true. Those are both correct. And oftentimes we are hoping to be able to reject the null and say, hey, listen, this person's cheating, or there is a difference between these two types of drugs. Now we end up with a type 1 error when we decide to reject the null, when in fact the null is true. That's a type 1. A type 2 error is we decide not to reject the null when it is actually indeed false. All right, homework 2 will be due 1 week from the class that we cover this in.